Well, hi there, boys and girls. Today we're going to talk about an angle measurement called radians, and they are convertible from degrees. And I know you're used to degree measure, and we're going to use radian measure instead in pre-calculus and calculus because it has a more natural place. And I'm going to show you what that place is, and then we're going to do some examples. So you're going to learn about radians and how to convert back and forth between radians and degrees. So the first thing I want to do is show you what a radian is. Now, 1 radian is the angle it takes for me to open up from the initial side of an angle to a terminal side, this angle of rotation, so that this arc length around this circle is equal to the length of the radius. In other words, I need this distance from where we start along this circle to be exactly equal to the length of this radius. Now let's overemphasize this. Let me show you what a radian is not. A radian is not, let's say, 120 degrees, because it's easy to tell that the distance we just traveled around this circle, this arc length, is much longer than the length of this radius. So that's what a radian is not. So this rotation right here was too much. And we can even look here at, oops, let me grab a hold of it. That is what I want to grab a hold of. Okay, even at 90 degrees, you can tell that the distance around this circle is too big for this radius. This radius is actually shorter than that. So let's go about where it is. It's somewhere in here. It's somewhere in there. And so you can probably believe that the length of this radius is equal to, if you were to wrap this around this circle, it's right in there. And it's actually works out to be 57.29 degrees, 57.3 degrees. And that is what we call 1 radian. It's the angle that you need to rotate in order on any circle for the arc length to have the same length as the radius. Let's take a look at a picture of it here. And this is a picture of 1 radian in any circle. And this always works out to be about 57.3 degrees. And that's a weird measurement, so we just call that 1 radian. Now, there happen to be about a little over 6 of these in every circle. No matter how big the circle is, you can go around the circle a little more than 6 of these radians. And actually, it works out to be closer to about 6.28 radians in one circle. And I'll call that 360 degrees. Now, if you remember that pi is approximately equal to 3.14, then it would not shock you to see that there are approximately 2 pi. Well, not approximately. I was going to say approximately 6.28. There's exactly 2 pi radians in 360 degrees. And this is how the formula for the circumference of a circle was developed. Remember, the circumference of a circle is 2 pi times the radius. And that is why, because there are 2 pi radians in all circles. There's 2 pi of those radii in all circles if you go all the way around. So this is the conversion we're going to look at. So this means that 2 pi is in radians is equal to 360 degrees, which means that 1 pi would be equal to 180 degrees, and we're going to use this for our conversion. So let's go take a look at maybe an example. Let's convert 45 degrees to radian measure. Okay, and this is how I'm going to do this. I'm going to start with 45 degrees, and I'm going to multiply by pi for every 180 degrees. Now, I could have also multiplied by 2 pi for every 360, but I simplified this. And I'm going to put a little 1 underneath that 45 degrees, and we're just going to multiply. So this is 45 pi over 180 degrees. And we're going to simplify this. Now, 45 will go into 180 exactly 4 times. And so I get 1 pi over 4, or 1/4 pi. And you will probably see this just written as pi over 4. So does it make sense that 45 degrees is 1/4 of pi? Well, pi is 180 degrees, or halfway around a circle, and 45 degrees is 1/4 of halfway around a circle. So this makes sense. That's one way of converting from degrees to radians. Let's see another one. Let's convert, I don't know, 120 degrees. This would be another example. Let's convert 120 degrees to radian measures. So I'm going to multiply times pi over 180. And again, you could multiply by 2 pi over 360, but this is just simpler. Let's go ahead and simplify this before we get started. You know, you can cross-cancel when you're simplifying fractions. So we can go ahead and knock off a 0. And of course, 12 is divisible by 6. And 18 is divisible by 6. And so it works out to be 2/3 pi. And we're going to call this, you're usually going to see this 2 pi over 3. So this is equal to 120 degrees. Now remember, pi is 180 degrees. 120 degrees is just short of that, and so 120 degrees is 2/3 of 180 degrees. So we're going to call that 2 pi over 3. Let's go backwards. Let's convert pi over 2 to degree measure. Okay, so the way we're going to do this is we're going to start with pi over 2, and we're going to multiply by, we're just going to flip that fraction over. There's 180 degrees in every pi radian. This is a simple cancellation, so those pi's will cancel, and we get 180 over 2, and I get that that's 90 degrees. Let's see if this makes sense. Pi over 2 could have been written as 1/2 pi. And since pi is 180 degrees, what's 1/2 of 180 degrees? Well, it's 90 degrees. So that makes sense. So there's a conversion from radians to degrees. Let's see one more. How about 5 pi over 4 to degrees? So the way we're going to do this is we're going to multiply by 180 degrees for every pi radians. We're going to cancel those pi's. 4 goes into 180 45 times. And so we just have to do 5 times 45, and that works out to be 225 degrees. So in short, or in closing, if you want to go from degrees to radians, multiply by pi over 180. To go from radians to degrees, multiply by 180 over pi. And I will see you guys tomorrow.